And programming side, that's my specialty with a little bit of mechanical in the background. This is my 4th year with First Robotics, and my hobbies are included up there. Today with me I have my son here, Austin. Say anything about yourself?
I'm just a senior here at Tech. My first year was Stronghold. I've been in it for 4 years though. I'm mainly just the head driver, do some build and software, and I just I'm part of football. I do some PC building and gaming as well.
That's the boring stuff. What we hope to cover, we're going to quickly build a robot program, right? No one really cares who we are unless you're trying to get a hold of us later. Use Robotbuilder to create the backbone of our command-based program. There is some chatter out there on Chief Delphi. If you've seen it, I'm about 50% through the videos. Chuck Benedict, mentor of Spartan Robotics, 997, saying the command-based robot template is broken. I'm halfway through it. I agree with him, but I'm an advanced programmer. For the starters, the current template works very well, but I expect to see some changes the next year or so. So we're going to stay with what's currently in the First Robotics. We're going to bring that code from Robotbuilder into VS Code, explore the parts of the projects, test some robot I/O, create some commands, create methods in our subsystems, test and tune a PID system, and link some set points to some buttons. We're going to have this robot with some motion moving on there. We're not going to write a single line of code. We will have to write some when we do the drive station, but the PID system, not a single line of code, and the tuning tools will be built for us using Robotbuilder. Next. So the pros of command-based programming is that we can develop and debug systems individually. If you have multiple programmers, and you can assign one programmer to the drivetrain, one to the wrist, one to the elevator, one to the claw. Those are some common terms that we see on robots a lot. And they won't interfere with each other. If you have an iterative robot with a big long string of code, you write one piece of code in the top, it could break everything else, where this is very modular and you can be very focused. We can create some complex autonomouses by stringing these commands together later on. If we don't get that to that in this hour, in hour 4, we'll be back in this room where CAD was supposed to be, where it can be open forum type of thing. I don't have a official slideshow. We can either go with this conversation or we can carry on from my next class after this with visual code. It organizes our code very well. Again, modularized. Easily split the functions and subsystems. And we can reuse commands. If we have a command that works really well in autonomous, why don't we map that to a button so when we're in teleop, let's just do it again. If this robot always shoots the fuel to the boiler from 2 years ago, line it up, hit the button, let the robot do the work. Some cons, it does look complicated in the beginning. You have to kind of follow a structure, but once you have the backbone in place, you'll quickly see the structure. And some of our hardware we do have to treat differently, like limit switches. You can't do a scan and look at the limit switch and carry on. You have to add some counters in there. And there's some really great tutorials on Screen Steps Live on how to use some of these inputs and outputs. And we do have to link and create our objects in a specific order, because you may have tried to create or use an object that hasn't been created yet. Next. So we're talking about subsystems. This is where we start dividing our robot into different chunks. And even on week 1, we're going to start to realize what we have and what we're going to have on our robot. We can already start programming a lot of these subsystems before we even have a robot in our, even starting to work on. It's going to be a lot of wood stuff. So things like gripper, driveline, wrist, elevator arm, mini-bot launcher, some explanations or some samples. Next. Some commands. These are what we're going to use to act upon these subsystems. What do we want these subsystems to do? Drive, move to a set point, elevator to a height, launch the bot. These are commands that are going to act upon those subsystems. So those 2 chunks in robot or in our code is going to be very isolated. There's going to be a couple other items in there. Robot, that's where if you are a programmer already and you're writing iterative robots, this is the auto init, teleop init, auto periodic, teleop periodic disabled. Those are those little methods are happening that the FMS is calling out while we're running it. OI is a little section where we're going to have all of our buttons presses, and that's where we're going to say, when this button's pressed, do this command. That command's going to act upon a subsystem. There was a section called Robot Map where we mapped up all of our outputs, like the motor controllers, in a nice little area. They have extracted that out this year. There's some chatter back and forth on the forums saying, is it good, is it bad? It's one of those hot topics. How a command works, we kind of touched base on that. We could string them together where drive to a goal, raise the elevator, set the wrist, score to organize these things. Go ahead. Sometimes we don't want to just do things in sequential order. We may want to run parallel. So as long as two commands are running that don't require the same subsystem, say drive and wrist, these two things can actuate at the same time. How's Robot going to help? How Robotbuilder going to help us? We're going to use menus and graphical user interfaces to build our subsystems, drag and drop a lot of stuff before we even get to the text code of it. It has error checking in it to make sure that if we do bring a subsystem in there that requires a two-motor drivetrain, that we're actually going to put two motors in there. If we have a PID system, we need a motor and an input of some sort. So it's some error checking that's going on. And we assign unique port numbers, either CAN bus port numbers or PWM port numbers. If you have two assigned to the same port, it's not going to work. I'm sorry, I might be standing in front of you guys over here. That's why I can see it anyways. So in this, we're going to drop menus to get all those items, create all the associations, and useful code. It is what it is. Without a line of code written, we're going to test some of the parts and create a wire map. This is where we're coding things up. We're going to have a robot program ready to go into the robot before the robot's even assembled. And we can create a map and say, we want this motor wired up to this input, we want this motor wired up to this input. If you don't follow our wiring chart, the robot won't work. But we can quickly go and change things if something happens. So we're going to start a little live demo. This is where we're actually going to see how long it takes us. This is going to take us a little bit slower because we're going to talk through it. But I can say when you get good at this, you can take your robot or one of your a robot that you're not even familiar with, you get a really good robot map of all the I/O. You could have up and running probably 15, 20 minutes, a robot with some autonomous is going. So you want to fire up?
It's open. Do you want it over there?
Yeah, we want to drag it over there. So this is Visual Code Studio. If you haven't heard already, WPI and for FRC are for moving away from clips and going to VS Code Studio. It's different than VS Studio, or Visual Studio rather. So we'll talk about this in the next hour. There's a one-click installer, but to start the tool, you can go over there, hit the little ellipse button, start tools. You should get a drop. It came up quick this morning. Hopefully.
I'll try it.
Do we have an instance of it open already? No. There it is. It popped up. So here's all the tools that you're familiar with. You can start Robotbuilder. This is the interface that we're going to get. The first thing we're going to see, we probably want to go start a new robot. I don't know where the status of this is right here. File new, is it just taking that long?
It's on the other screen.
It's all on the other screen. You drag it over so they can see what it looks like. We're going to create a robot. We're just going to call this Jumpstart Demo. Put your team number in there. It's going to create this robot. Some of the things over here, you can see, what's that called over there now, export directory. It's where the file, where our little program's going to go. We're going to leave it right in the default spot for today. But if you have a special spot you want to put it, you can put your program where you're going to store it. And I'll have all these slides available to everybody too. It's most of these presentations. So we're good in there. First thing we can see on side, we have subsystems. We have on the left-hand side from your view, we have a column of different items. The first thing are a couple different subsystems. A normal subsystem, PID subsystem. The green area, what's that? What are those? Controllers, where we get some PID controllers, some 4-motor controllers, 2-motor controllers. They've added the differential mechanism, some of the special drivetrains. The 2-motor and 4-motor controllers are depreciated, so we should stop using those and using the other. That'd be like your drivetrains. Then we got some sensors we can drag into our project. Some pneumatics, or what's underneath there, that's our speed controllers. Gyros in the purple. Red are our motor controllers. Purple's our pneumatics. And green at the bottom is some of the commands that we drag in there. There's two ways we do it. We can drag a command. We'll do it one of each way. Go all the way to the top, AJ. We're going to drag a normal subsystem into our robot. Just drag and drop right into subsystems. And I like to call everything my, so when IntelliSense, you can start typing my at the beginning of when you start coding, and IntelliSense will start bringing up your methods. So we'll call this my drivetrain. And the thing is, a pro tip, as soon as you drag one in there, you can start typing. The cursor is in the right box, so you don't have to click in there. And that's all we can do right now. The other thing we do is right click on subsystem, we're gonna add a PID subsystem. Where this little orange dial on this robot here is gonna be, we're gonna call it a wrist, like a 0 to 90 degree wrist. So we're gonna call it my wrist. Call it my wrist?
Yeah.
Okay. You can see these items are they red right now?
Yeah, there's input and output are red.
Okay, let's go to my drivetrain first. We're gonna add a differential drivetrain. So we go down, grab differential drivetrain, or right click and add it. Now there's some errors right there. What it's looking for? It's looking for 2 motor controllers or controller groups. First motor we're gonna do is we're gonna do a right motor. We're gonna add a speed controller to our.
You want speed controller group?
No, the speed controller.
Just that's all.
Add actuator, speed controller. Did you add 2 of them?
Yeah.
Okay, the first one, let's call that motor right. If you put spaces in here right now, Robotbuilder is going to delete all of them out of there. I can tell you as coders, you're going to become the worst paper writers. You're going to capitalize words in the middle of your sentences all day long. You're going to, because you want emphasis. My wife hates it. It's just how it works. I mean, I can't get over it. So, you know, if we want, since they're going to be concatenated together, capitalize and everything. And it will lowercase the first letter if Java or your code script kind of system. Yes?
Do you know why they switched from Eclipse to Visual Studio Code?
I don't know the exact reasons. One of the big things, we'll cover that in the next hour, is we can have parallel installs. Right now, if you want to go back to last year, like, or 2 years ago, you'd have to basically uninstall all the packages from Eclipse, go find the new ones, install the new Eclipses. When Java, all the different Java versions that are coming up there, you'd have to go change your environmental variables to what version of Java this particular project needs to do and add those pointers. Here, they're creating a package in one folder. Everything you need is in that folder, and then 2020, everything you need will be in that folder. So as they move on, you'll be able to jump back and forth and not break any code. Yes?
Is that why when, like, I tried to load up Eclipse on my computer and it wouldn't load? Is that why that could be? Because it says that the code is corrupted for some reason.
Code from last year? I'm not exactly sure what's going on there. We'd have to do some really deeper investigations in there. You can go to screen steps and you should be able to still follow the 2018 system. What's that?
What did you say the error was?
It said that like, the code was corrupted.
Oh, it's probably because your workspace changed. That's another thing that's really bad about Eclipse, is that Eclipse likes to change workspaces. I've been using Eclipse for 5 years now. I've been through FRC. Eclipse is horrible. Worse than horrible. I took a Visual Studio class. I've never had a problem with Visual Studio.
I have been beta testing the Visual Code Studio this year for Java. It's a good experience. Yes?
I think error at the start of the year because I'm using Eclipse and you just have to go change your environmental.
Okay.
Change to Victor.
Changing the Victor, the controller we have our Victor, PWM 0 is on the right, left is 1. And then you've probably seen up in Drivetrain, if you go by Drivetrain, they were errored out because it auto-populates, go to Drive, there, where the motor, that right there. It auto-populated the first one into both drop boxes. We just had to bring that drop box. How do you have to change it? My drivetrain. The drop box for the motor, right underneath that where you changed.
Yeah, I changed them.
Yep, bring the drop box so that we show them. You see everything, all the motors that we listed. If we listed inputs, they would not be listed here. Only things that are valid to fit in that box will be listed in that drop box. Okay, moving on to our PID subsystem.
Yeah, just keep going.
We're gonna add, if we open a PID subsystem, there's 2 errors there. It needs it needs an input and an output.
Yeah.
Well, for an input, we're gonna use an analog potentiometer. On the back of here, on that big dial, there's just a 270, and actually this one's a 320 degree potentiometer. We're gonna call that pot, or what are you changing?
I'm changing the name of the drivetrain because I have 2 things named the same thing. It's fine.
Okay.
We're fine.
I think I'll stand over here on the wall, because then I can read what you're doing. take the motor, take drivetrain and call it my drivetrain. Back subsystem drivetrain, call it my drivetrain.
Yeah, I think it changed the wrong thing. There.
That'll help in the beginning. All right. So the wrist, we need an input. Click on that pot that you added. There's some information we do know about the pot. We're gonna call it pot. We're on analog channel 0. Full range, like I said, that's a 320 degree potentiometer. So we're gonna take that 1 and just change it to 320. You'll see why here in a little bit. We will come back and look at that offset. We're gonna use that offset a little later. But we also, like we said, we need a motor. So we're gonna add a speed controller, actuator. We're just call this motor. Case in here we have a Vicker SP. It's on PWM channel 2. You can see how these numbers are automatically incrementing. So if we do everything in order, it's going to automatically increment as we have. So once we run out of PWM channels, it's going to tell us. But typically we use a lot of CAN stuff, but this demo bot we didn't. So now wrist is happy. Next thing we can do is we always have an operator interface, a joystick or something. Today we're going to use an Xbox controller. So on the operator interfaces, we're going to right click add joystick. We'll call it my Xbox joystick. And we need to know what channel. We're going to have multiples between channel 0, channel 1, and we can use the driver station to determine those things. We're going to add a couple buttons there for use in a little bit. We'll start with button A. And everybody know how to find out what channel the buttons are, what button number it is using the driver station? One of the tabs in the driver station, so we won't review that if that's okay. B is channel 2. And you see these are all aired because they need commands. You should, once you add them, you add them all quick, that's why. A, B, 2, and Y is 4.
Button 4, yeah. B is 2.
We'll come back, yeah, that's 2. This one does not auto number for you.
Could we set some constants first?
Oh, did I skip that back there? Yes. We can come back. This is the thing, we can come back. We're going to go to my wrist, the subsystem. Up in the top, there's just some constants. The second, these are some information we're going to store in our subsystem of where we want this robot to actually go. So we're going to say up is 0. We're going to create some constants. Usually constants are all capitalized, so it's nice to try to keep some of the conventions up there. It's going to be a type double. We're going to change all of them later.
What do you mean?
Mid 45. You got to change the type to doubles. Mid 45. We're going to say like this. What I'm kind of modeling here is that year when we had to deliver the gear. We had up, we had down, and we had kind of a mid position to present our gear to the peg. The reason this is broken right now, later on in my steps, there is a bug report in, and we'll show you. We can get around it though. So, thanks for catching that, AJ. So some commands. We're always going to need a few commands that we know about. So the first one is like we call drive with joystick. So a regular command, we call this my drive with joysticks. This is where we set our requires. You'll see where this requires comes to later, but it requires the drivetrain. And there are no other parameters we need there. We're going to add another command. We're going to add a time command. Yes, there is an add a time command, but we're not going to use that today because I want to show you how another method inside the system works. So my drive time also requires the drivetrain. We're going to create a parameter. No, go back to that. Create a parameter. And this is going to be timeout. This is where we're going to set a value of how long we want this command to run. And it's going to be a double. It's fine. Save and close. And we're going to add a parameter preset. This is just something for it to use in case we don't pass it something. He's working over there. We should maybe just not do screen sharing. And this is going to be, we're just going to call this default. And set it to 5. We could add a whole list of presets here if we wanted presets. You can think of these maybe as encoder pulses too later as a timing of an encoder. The next command we're going to add is my wrist to set point. This is a special kind of, it's an add set point command. This kind of acts upon a PID subsystem. And it's going to require our wrist. So then what we have those parameters. It requires we're going to do some parameter presets. These are what you see that little check button there for buttons on Smart Dashboard. We're going to get a whole list of buttons already on our dashboard to test this with, and we're going to be using our buttons to mapping. We're going to add 3 presets. We're going to add stow, which would be our up position. This is where it's broken. If you click the 0, there's a little drop arrow right there. You see all of our parameter, our constants that we added are now listed here. We could select one, and that would be mapping to it. So now if any other commands are using, we can have one common spot to have constants. It's broken right now. It doesn't stay populated here, so we're just going to have to repeat the numbers in there and hard code the parameters into the command, which is unfortunate, but that will be hopefully fixed. It worked last year.
You want stow at 0, right?
Stow at 0, present at 45, and pick at 90. There's a couple of, so now we have some commands we can use. We can go map some of our buttons to it. We're going to go back and fill in some of the blanks here. So A button on the joystick, where is that located on the joystick?
On the controller at the bottom.
At the bottom, so
Okay.
pushing down would be logically picking it off the ground. So we're going to assign this button a command, which is risk to set point. And what set point do we want actually? Did it go to the other screen?
Yeah.
We'll be able to fix this the next hour. And some of those set points we added to are now listed in that Dropbox, so we'll go pick. Save and close, continue with the other buttons. B button's in the middle, so we'll do that present. If we get to a talkie point also, maybe we can just change that to screen sharing or something. Pick. So
No, still.
it's 0, it set it to 0. Good. One final little comeback to is up in the drivetrain. We can assign default commands to our subsystems. If nothing is using that subsystem, what do we want running? So typically, our default command is assigned to none right now. Is there a drop list? We're going to assign that drive with joystick. So if we're not using the drivetrain, we're probably driving it with the joystick. So no, we're going to assign that. And the RISC doesn't have any default commands. So we're done with Robotbuilder right now. We can save our program. It's always usually good to save before you deploy things, because when things crash, save it to the desktop for now. I'm gonna ask them to auto-populate that thing too, because you have to type it every time. And we're gonna hit that little Java. If you're a C++ guy, you hit the C++. If you're a Java guy, you hit the Java. It's generated our code. It has generated all our code. Now up there, there's also wiring tables, so that's where you generate the output tables. So here, we're coming back to VS Code. We go to File, and it's not a workspace anymore. It's unfortunate it's there. We're going to open a folder this year. So open the folder,
Open file.
and open, yeah, I think it's already there. It's in Libraries, FRC Projects. I added a quick link there. Right, down one more. There's our Jumpstart demo. Open the folder.
Open the file. There we go.
So we haven't written any code yet, and here's what we got. We're going to kind of explore some of our tree, our project tree here. Right away, you can see in our commands, if we expand that, we have our drive with time, drive with joysticks, risk to set point. If we go into the drive with joysticks, you can see all this code that's in there. See this begin and end? These are the section Robotbuilder is manipulating. So when we go in here and start adding our own code to these commands, we want to make sure we stay out of those comment blocks. Or we have to delete those comment blocks, the begin and end comments. Now Robotbuilder will say, okay, it's all up on you, and now we're not taking care of it. Typically what we find is we're in Robotbuilder the first week, and once we get so far into it, we abandon Robotbuilder and we just start hard coding from that point. We kind of created our backbone and we move on. If we do need to use something special in Robotbuilder, maybe we'll create another project, generate that little chunk of code, and then just copy it over. So inside of every normal command, we'll see there's a constructor where it sets up our requires. Initialize. And what initialize does is when we hit a button, this happens one time as soon as we start the command, and then we move on to execute. Execute every 20 milliseconds for a scan cycle. This code will happen. This is where we're going to pick up our joystick number values and send them over to our drivetrain. Is finished. We're going to use that in the timed. But is finished is if we set like encoder counts and maybe some kind of autonomous thing. When these encoders equals this, we're going to call this is finished true. Is finished true, we'll call end. End is a little area where we can set up some cleanup, where we shut down motors, we set some variables if we need to, saying something was done. And then interrupted. If for some reason we're driving and some other command says, I'm taking over this subsystem, the interrupted method will be called, and that's where we, again, can do some more cleanup. And typically interrupted, 9 times out of 10, we'll just call the end function. We're going to do the same thing in our slide there.
Right now. Do you want to just right now?
You want to do that right now, so we don't do it later?
No,
Sure.
we're not supposed to write a line of code yet. So we'll
No, yeah, we're not writing any code yet. You're right. Let's go to my the set point command. Same thing is happening. Some same sections are in here, except for here we see initialize. It already has some populator stuff. We're going to enable our PID controller, set the set point to the value that we brought in up in our constructor up top. Execute has no code in here. Is finished is already populated for us. That's saying, hey, our PID controller is set to set point. So the command is this is where our PID is done. We'll look at some subsystems. First thing we're going to do is the My Drivetrain. Here's where all of our devices we assign to this subsystem are constructed at the top there in the constructor. They're declared up top, constructed, set to the ports. All these add childs are automatically added to it. We're going to push up buttons to the smart dashboard so we can see what's going on there. We can move motors and start testing polarities. Default, set the default command. We do have a new periodic that was there last year. That's just called inside the subsystem over and over if we have to do some monitoring. And way at the bottom, that's where we're going to write our methods that we're going to set our motor controllers. Want to click down there, AJ? No, put all the methods for controlling the subsystem here. Right there. We're going to put all of our code underneath there. Take a look at the My Wrist. Here's our PID subsystem. You can see those constants that we created, 0, 45, 90 at the top. We're declaring our potentiometer and our motor. The constructor is constructing the PID controller, setting our PI and D values, setting our tolerances, which we can adjust all in Robotbuilder. We'll look at some of that stuff. We're constructing our potentiometers, motors. Default command, we didn't assign a default command. Our return PID is already returning our potentiometer. To use the output is going to turn whatever output our motor, and our PID controls the loops. Look at our I/O. A lot of information here. So some instructions, and it's very well documented on what to do inside these sections. We're declaring our buttons, our joysticks. We're constructing them or assigning them port numbers. Down here, we're adding all these buttons to our smart dashboard, and that gets really busy sometimes, so you may want to come over here and delete things at times. But you can see even the buttons are up here, and they're already saying use, and there's our set points that we hard coded. That would actually say subsystem.constant in there, but we had to hard code those, which is unfortunate. That's it. And returning our joystick. And then our robot. This is, if you're coding in the past, this is going to have a familiar look to it. We have our robot init. That's where we're going to create an instance of our drivetrain, create an instance of our wrist. Now that we've created those subsystems, we can create an instance of the I/O. Set up our auto chooser, should be choose to. You can do a lot of that in Robotbuilder. We typically don't, because by the time we get to the autos, we're out of Robotbuilder. Then scrolling down, we got the disable, the periodics, and pretty boilerplate code. Not much we need to do in here ever. So now that we kind of took the tour, let's deploy the code to the robot. But we haven't written any code yet, really, right? It was all generated for it.
Use the 3 dots, yeah.
Yeah, so there's 2 ways of doing it this year. You hit the 3 dots, we can deploy robot code, or you can see that shift F5, not control F5. I think that's debug. We found that a couple times. What's going on here? Question over there.
You do control shift P and it opens the command palette, and you can just do like WPI.
Yep. There's a couple ways. Yeah, you can hit, so that's more covered in my VS Code thing, but yeah, there's that little W in the upper right corner there. If you click on that, that opens the command palette with all the WPI tools. There's a whole list of tools on shutting off, turning on, setting your team number, deploying code. There's a whole, all the tools that they've created, little methods. That's the nice thing about the VS Code is they were able to write a lot of add-ons.
So does the Visual Code Studio work like exactly like Eclipse did, but it's just, or is there any like changes to it?
They're still IntelliSense. If that's, I mean, they have a similar feel. It's just it looks a little different, and they're allowed to do a lot of, I like to add a lot of those tools to the builder. So in the linting, there's I already shut it off here, but Visual Code. If we push code to it again, you're gonna, and I have that on the bottom of there. There's some pro tips in there. I already shut them off. You're gonna get a copy of every thing that Robotbuilder does with a little tilde at the end. That's basically a backup. When Robotbuilder is going to write code, it creates a quick little backup for you. So if it does get all hosed up, you can refer back to the one step back. The other thing about Visual Code though is it has Git integration very well tied in. It just works well. There's not a lot of anything you have to add to it. This one-click installer, there is one little package you have to install, and that's covered in the VS Code session in the next. But it's very similar. You'll be comfortable. You'll get a hold of it pretty quickly. So, did it deploy?
Yeah, I did.
So bring up that and bring over the smart dashboard.
Shuffleboard, yeah.
Shuffleboard. Yeah, we use Shuffleboard. So right away, we're gonna go into test mode, and we're gonna enable our robot. What that's gonna do is that all these, and it's kind of a little bit of a mess right there. We're gonna have to clean things up. Great. There it went. No, go up here to File, go New. Now live enough, there we go. So all these objects were created for us. Now we can start testing, is our right motor right? So we're enabled, run our motor. Run the right motor, run the slider. So we can determine, does that motor work? Yes. Does the other motor work? Positive direction, yes. Well, let me disconnect this belt right here. When we're going to go into PID system, especially if you have it can lock up hard, you're going to want to decouple the mechanics of it. But we can turn our wrist motor to a positive direction. Observe the direction of the motor. It's counterclockwise. Shut that off. And now I'm going to look at that potentiometer. As I turn it clockwise, it goes positive. When we set up PID controllers, we want the input and output to be in phase. When a positive command is a positive result. So we have that in phase. And if it's wrong, we either have to flip the motor in software or reverse the wires on our input. Whatever it takes to make sure positive is positive. And usually it's nice to always have logical, physical, mechanical movements or positive, up, those kind of things. So, let me get caught up here. Any questions? So we verified these things. You can see this system controller here, this PID controller. We have a nice tuning tool to start tuning on. This is where the magic of Robotbuilder already creates a single line code. And you can do this hard coding yourself. But we're going to tune our PID controller. We've already verified positive is positive, negative is negative. But the first things we need to do is figure out, in a PID controller, we usually don't want to hit our hard stops. We're going to set actually this 0 volts. We're going to go all the way up, we're going to 90 and say that's actually our raised position. So but we don't want to say go to 90. We want logical that to be 0. This again is broken too. There's a fix in it. This is in voltage. Our input's 0 to 5 volts. So we have to kind of convert that over to our user unit. They used to display whatever our scale of the pot was, so that should say 0 to 320 and just read it to us. But we can do some simple math by just doing our, cross multiply and divide. So what we have is 2.25 volts times 320 degrees, our full resolution of the pot, and divided by 5 of the voltage, it equals 76. So let's go over to Robotbuilder and fill in our offset. And we could go into the code and hard code it too. This is where our offset is set to 0. And what that, we're going to go negative 76 because we want this to be 0 and that's going to be negative 76. So we set that to -76. That's our new 0 now. We won't mechanically bind up our input device.
You want to confirm the motor stops and reaching the set point and all that stuff.
Yeah. We'll do that here.
Just tell me to push this down.
Sure. Just give us that. So actually, if we went into my risk subsystem, just to quickly look at it, the subsystem, you'll see on the constructor at the top that this value got changed to us already. That's where we would physically change it. Your question here?
Does VS Code have native hooks, or do you not have to worry about that?
Don't have to worry about that this year. Yep. Because VS Code is not an IDE, it's a text editor. It's essentially a really powerful Notepad++. Another question? No? So,
Did we set our min maxes?
should we do that right now? Sure. We'll go to my risk subsystem. Some protection. If we don't want our coder to say, hey, go to -10 degrees or go to 100 degrees because 90 is our physical max, we have some inputs in here. We can limit our input. We're going to check that box. And we're going to limit our input to 0 and 90 degrees. Those are anything else. If a coder says, I want to go to 110, it'll automatically force it to the max. So you can say go to 110, it's going to say nope, 90, and it's going to automatically adjust that for us. And also you can limit the output. If for some reason you don't want 100% power throughout your stroke, you can say, you know what, even though the PID controller is saying go 100%, limit it to 90% or 75% to slow things down. You just don't want that full. It'll redeploy. We're doing all right. Yeah, we're not going to get to the commands today, but we'll get that in the third hour. We're going to come back to string commands. Stringing them up in the command groups. Your enable. We're going to start setting some values up here. So the first thing, we're set to 0. Enable the PID controller. It's going counterclockwise. If I move this down a little bit, I'm hunting for the 0 right now, right? I can't quite get there. Set it to 90. And now I'm going to move this. Yep, that's about where I would stop there. So we're kind of verifying that the PID controller is trying to work, but we're really hot. So disable the PID controller. Now that I know the mechanics are somewhat working and the inputs all in scale, I'm going to hook up. This PID system is a really floppy belt. So it's really hard to tune. So now we're going to start tuning our PID controller. So re-enable.
Just leave it at that.
And what I call this is really hot. So we can start dialing down the P value. You can do it live while it's running. So let's try it. What do we end up with, AJ? Let's go 0.5. 0.5. But put like just put 0.1 in there, or put 0.1 in there. And now I'll go to set point 0. Still a little hot. So that's where we start tuning it down here. That's where we ended up with that 0.05. So we can start going back and forth and tuning our PID controller in here. You know, typically P is enough in most cases. D is that derivative. It's to try to make sure we don't overshoot. I is that to get us to that set point so we don't have like quite enough power there. And feed forwards, also we could set all those things. So now that we have that information, let's go back to Robotbuilder. And the reason that we're not doing it in Coder now is because we're still kind of using Robotbuilder as a tool, so we can record that value up there in, as our P factor. So how much code have we written yet? 0. We're going to redeploy this. And we will be able to get that drivetrain program here. We have 2 more things to point out. We're gonna go into teleop now, and enable. Go to the smart dashboard, the first tab on shuffleboard. All these buttons right here, we can wrist to set stow. Hit that wrist to stow button. It's already there. Hit some of the other buttons. We're actually controlling in our PID system. Now, and remember we mapped some buttons, so if we hit the A button, we'll go down. The B button, we'll go to present. Y button, up. We haven't written any code and we got a working PID controller. So now we can move on. We're gonna do our drivetrain. We're gonna kind of skip through this pretty quick. And is there any questions up to this point?
What time are we now?
We have until like 55. Here's where we're gonna have to start writing a little bit of code. Go into the VS Code. First thing we do is we need a method inside our drivetrain subsystem. My drivetrain subsystem. We're gonna down here at the bottom here, we're gonna do a public void because we're not gonna return any information.
Out here.
Right there, yep. Tab over. Public void. And I called it, what do we call that over here? My drive arcade. Enter. Oh, hit enter inside the brackets. Get the bracket down. And here's where we're going to act upon our drivetrain. So we're going to go drivetrain dot arcade drive. And we'll just do the simple one right there, speed. We need a speed and a direction. But I hate typing, so I like to do copy paste. We're going to copy those two parameters into the method variables, right into the parentheses there, right after my arcade.
Oh, right here.
Yeah. And those have to be double, so we have to set the variable, the dap type is double for each one. Space and rotation.
Hey, Court,
Yes,
you are actually done at quarter two.
I am, huh?
Yep.
Oh, hit save. Oh, we'll get here. Hit save.
Control F.
And we got to go to our drive the joysticks command. In the execute, that's where we're going to go robot, capital R, dot drivetrain, my drivetrain, dot my arcade drive. That's where I like to put arcade. We need speed and a rotation. Since I'm running out of time, what we'd do there is we'd copy those out, create two variables, go get our joystick values, plug them in there. So we'll skip that, AJ, for now. So right above here, we set our joysticks, plug them in there. When we're running the default command, these will be scanning. If something cancels it, down here in end, go down to end, AJ. We're gonna do that, write that whole string again. Robot, my drivetrain, my drive arcade. We'll set them to 0, 0. So that way, if this command gets canceled, we're shutting the motors off. So the robot doesn't go spinning off through the wall.
End or interrupted?
In end. Set 0, 0. And again, what a good idea is in the interrupted, call the end method. So. Yes?
I just have a question. For Visual Studio Code, what doesn't it have that doesn't make it an IDE?
I don't have the answer to that. Good question. We're going to hopefully cover a little bit more of that visual code that we kind of spun off in. I expected that a little bit. Any other questions? We're going to go, after lunch, we're going to be back in this room. It's going to be an open. I have no slides, no nothing. We're going to experiment. It's going to be on you what questions between the VS Code and this. We'll start stringing out commands. The command groups are what really make this powerful. That's where you can say drive forward, set the wrist, drive forward, set the wrist, raise the elevator, and string these commands all the time. I should have printed this. I had a hard copy of myself. Alright, I don't know how long you guys take me, so we'll get started here. A few minutes early. So, GoPro. So welcome to Switching to VS Code. My name is Corey Applegate. I'm the mentor for the Granitecitygearheads. I'm coming into my 4th season here. I didn't do a introduction slide, so I'll have to do it on the top of my head, but I think I know who I am. I've been working 21 years as an industrial electrical controls technician over at Electrolux, working at the Rockwell Automation, KUKA, Fanuc Robotics, and a lot of other automated equipment. Again, 4th year on the team. I am the programming mentor. I'm the main mentor, #1, and then do a lot of the build side of it too. So I wear a lot of hats. Today we're going to talk about that switching to VS Code. I'm guessing many of you have already by now heard that FRC is moving away from Eclipse and going to VS Code. Today, running the slide shows me is Austin, and just a couple things about yourself on the other slide. Not on this one, but.
So I'm just a senior here at Tech. I'm 4th year on the team. My first game I was part of is Stronghold, and I'm just kind of the head driver, and I also do a little bit of code, a little bit of build, just a little bit of everything as well.
So, big question is why to switch to VS Code? This is straight from Screen Steps Live. As part of the continuing improvements, the FRC control system in 2019, our current plan is to switch from Eclipse with the built-in ANTs, and if that means something to your advanced programmers, you probably wouldn't be in here. But that supports the IDE, C++, Java, and going to Microsoft Visual Code Studio, using the Gradle, which is a community build project, Gradle Rio, and it's brought underneath the WPI umbrella as building deploy tool. That's straight from Screen Steps. That's why we're doing it. Installing VS tools. Install development tools to Windows, Macs, or Linux machines. New this year is a one-click installer. And with every one-click installer, there's usually a couple of things you do have to install separately. But generally, the setup process, once we install VS Code, WPI is going to be in there, and we're ready to hit the ground running. We don't have to go do a lot of retrieve repositories and update repositories. It's kind of all built right into the one-click installer. And they're moving to a Java Open JDK. This year, I think we're going to be at 11. I don't remember the numbers, but it's all that Java is installed in the one-click installer. It's just done. The benefits for the VS Code is we now support side-by-side installations. That means in 2020, the installation, if they move to a different Java, we don't have to uninstall or repoint our pointers to the old Java programs. If we want to go back to last year's, we can go to that folder and that environment set up ready to go. So we can do multiple year side-by-side installers and not have to worry about backwards compatibility or reconfiguring things. Also, the big thing I found is that it's VS Code is has very good Git integration on it. There is one small package you do have to install. The one-click does not install. You have to install git sm. It's on SCM. You go to their website, and that's a hyperlink. All these slides will be available to you. I think they're also on the sheet down there, some links. You have to install that to get integration working. So what's going to happen is we're going to go to screen. Everyone's familiar with Screen Steps Live? They're still going to have the full installation tutorials of here, install this, download this, and it's written very well, put together. The links will be available after kickoff. I am part of part of a beta team, so I've been looking at this stuff for a while now. You're going to download your package, and it's going to look something similar to this. This install full Windows 64. First thing when you launch this executables, you're going to say, do you want to install to all users or current users? Pretty simple. That's really on you. All you, depending on your PC and the environment. Why we install the first time we install VS Code, we will have to be online. There is one package, and that's actually the VS Code installer. Can't be bundled in. So this one click will go download it for us. Right out here, you're going to have this select download VS Code. Open up this window, hit download. It'll download the files. It's going to it's going to copy it into a zip file. The zip file is going to be called offline VS Code files.zip. You can now use that zip file to install on other computers later on, so you don't have to be online anymore. Once you're done, or go back to that slide. So you downloaded it. All these checkboxes will be checked. These are the tools that are going to be installed in the one click. Execute install. It's going to take off. You can walk away for a little while, come back to it. It's in your environment's, I'm going to say about 99% ready to go start coding. On the desktop, you're going to get a new icon, this FRC Visual Studio VS Code. You will want to launch using their icon because that's just going to open up all and set up the environment. It's going to be ready to go for you. Anything I missed in there? I don't believe so. No, give me the next slide. So this is one of those not one-click parts. This year, you will have to install the cross-the-road electronics, and they call it the diagnostics tool, if you want to even look at any of the CAN bus stuff. It's been pulled out of the WPIs, or not WPIs, the NI Studios web dashboard on the RoboReel. And so there's no access to the CAN stuff. So you'll have to at least install the cross-the-road electronics diagnostics tool. Just look at the PDP, pneumatic control modules, and then obviously any Talon or Vickers SPXs that you might have on the CAN bus. So it's been removed from the dashboard. So you're just going to follow their third party. And again, it's one of those one-click installers. Yes?
Where can we find those Google slides?
I imagine we're going to be pushing these all up on the Jumpstart website. Otherwise, I'll be sending some links out too or something. Well, I don't know exactly where they're finding it.
You can always contact us at granitecitygearheads@gmail.com.
Yeah.
Talk to Todd when we're done. Todd will get you a slide.
So yeah, there's a link down there for the VOD will be up on Twitch as well. In that Twitch VOD, we'll probably send some links up there. Third party. So once we're done installing, we open up our VS Code. We're going to be presented with this welcome screen to start running your first project. And the first thing you probably want to do is import your last year's project. So there's a couple ways to get to the command palette. VS Code, and then anything we do, there's always 3 ways of doing something. We can, over on the upper right-hand side of the window, there's going to be a little red circle with a W side of it. That will open up this command palette with all the WPI lib pre-configured little modules that they've done for us that we can debug code, deploy code, or we can do the Control-Shift-P. We'll bring up the command palette, and then we have to type in WPI lib as well. And there's a lot of quick keys in there. I think I have some of those on the tips and tricks down there. So the first thing we're going to do is probably import last year's code just to take a look at it. So when we get up to that command palette, we're going to say import code, Java code from last year, Eclipse project from last year. You're going to select your Eclipse project in box 1 by hitting the box, and you'll have a browser to go browse for it. 2, select the new project folder. Where are you going to store this new project in? You can't store it can't be in the same folder, but it's going to import it all there and put all the Gradle information that has to be on there. Create the new folder. Name the new project. You may want to kind of do a little subscript on there saying, import your VS Code import so you can easily identify it. Set your team number on button 5 and then import the project. And I should get a, the other thing we might want to do after, I think we'll go through that. I think I have it in my slides. I can't remember anymore. Is create the new project. Same wizard you're going to get. You're going to go to WPI, the command palette, pick up create new robot. Select the kind of project you're going to do, and we'll go through this here. Select the language, the base template, whether command, iterative robot. It's a really great wizard. Put in, again, the project folder. Create the new. We want to make sure that create the new checkbox is checked. Just makes things easier. Name your new project, team number, and then you generate your project. Next. The other thing we have to do here, after we install our cross-road electronics, all those tools in here, once we open up our project, if we're going to use any of those libraries, we do have to bring those libraries into our project. And what we do that with a tool that they created, manage vendor libraries. There's, again, multiple ways of getting in there. One of the things to do is you can right-click on the build Gradle. You'll have a menu down here that says manage vendor libraries. When you do that, you'll get this little option box here with install new libraries offline. Or you can go come up to Control-Shift-P, WPI, manage vendor libraries. Once you click on this, you're going to get this window right here, and you'll have all the vendor libraries that are available for you. Check them all, import them in. So NavX, cross-road electronics, those type of things. Launching the tools. If you're a path, new this year's Path Weaver, I haven't had too much time to experiment with that yet. Your smart dashboards, your Outlook viewers, Robotbuilder, shuffleboards. You can again hit the three little dots off to the side, launch tools, or WPI, go to command palette, launch tools, and you'll launch, pick your tool you want to launch. So you're going to launch the Robotbuilder, launch it from here. There is a folder, a tools folder in this one-click installer directory that will have all these tools in there as well. We're all used to clicking on the jar file to launch the tool. This year you'll not click on the jar file, there will be a VBS file in there. Since all of our current Java the current Java version that we're in is in that folder, that VBS will use the correct for that year Java. Java stuff. Some really kind of pro stuff, user snippets. Once you start getting into this, if you have the same line of code that you seem to write in every program, or the same chunk that you usually go and find your code, copying it, paste it in there, you can do what's called user snippets, and it'll be basically your custom IntelliSense. When you start typing, all of a sudden you'll get it, oh yes, that's what I want, and it'll populate the program for you. I have been starting on some snippets like command choosers, auto choosers. Those are always just one of those things that we always seem to build a lot of. So your snippets, and you can actually go in there and set hot placeholders, and you can do tab in there and fill in the placeholders as whatever it's going to be. So it's a really cool addition with this VS Code. And the integrated Git, again, install that Git SCM extension. There's also a VS Code VS Code extension called Git pull request. If you're kind of like the chief programmer, and anybody, if you are strong using Git, if you have a programmer that's going to do a push request, you can now bring those push requests right into your environment, and you can actually, all your IntelliSense and all your quick keys and your will work in there, and you can monitor, look at their code, and not just on the text base like online. Be brought right into your, something I just discovered about a week ago, that I was like, this is amazing. Let's, that was my slide. Jeez. Apparently I didn't, I know why, because it skipped over there. We'll go through some of those steps now. Open up VS Code. I had that screen hidden, so I got to get tagged. Any questions? We're going to go through this live, kind of, too. Yes?
When you install the VS Code through the one-click installer, does it overwrite your previous installation, or how does that exactly work? Because I know it influences the WPI lib interface. Does that ruin your current VS Code, or how does that? Is it a separate install?
Current VS Code,
if you already have it installed for something else and you're not trying to always use it for WPI lib, is that a separate?
Yes, if you already have it installed, you're going to have to install this. It actually, open up Windows, go to a Windows Explorer. Just that folder down there. If we go to C, users, owner in this case. Sorry, scroll down. Check that, go back to C users, the public. I don't know how to explain it, I can just go there. One of those things. There it is. FRC 2019. This is the folder that is created with all of our complete installers. So in 2020, we'll have another folder in that same directory, say in 2020. So your current VS Code app will be all by itself in its own entity. I rifled through that slideshow because I didn't get the. So the first thing we did is we imported a project. So file. No, we're not going to import. We're going to go hit our bring up our command palette. Import WPI Eclipse project. There it is. So we're going to go select Eclipse project. Let me go to C. This is our robot from MRI. We'll select the project. We find our build properties. That's what's going to bring the import in. Where do we want to place this? Go to C. FRC. New folder. We'll call this import project. Would you like to open the folder? Yes. So, like I said, we imported the project. We are using a lot of Talent SRXs in this program. So the first thing we're going to do is we're going to import the vendor libraries. So go to Build Gradle there on the project tree, right click, Manage Vendor Libraries. There it is. Install new libraries offline. And there we use the NavX and the Crossroads, so click both of them. And it'll generate a little file off to the side here saying vendor. Okay, yep. Vendor deposit. So we're in there. Now we should be able to update our Rollerio so this courier's firmware, deploy the code, and start experimenting. It's done. New project. All right, any questions with that process of importing? You want to look around in the code, it doesn't really change anything. Questions? I didn't rehearse this particular talk very well here. Let's go to let's create a new project.
Just new file, a new window?
No, we're going to go to, let's go do a Control-Shift-P. Let's show them that way. And now start typing WPI, libs, import. Let's look at that list a little bit here. Hit that scroll so we can import, set team number, start a tool, auto start the real log. I like to shut that off. It's kind of I don't like to see it in there, but we can shut that real log on and off. Manage vendor libraries, your C++, build robot code. Open. So where do we got create new? Is that up at the top?
Create new project.
Create new project. So select project type. Up at the top, we want a template or an example. We'll go with a template here, but you could open up all the sample programs that they have. We are a Java team. What type? We typically do the command-based robot. The command-based robot, there is a little chatter on Chief Delphi out there that what was his name? I have it written down over there. Spartan Robotics 997. Pardon me?
It's me, Chuck B.
Chuck B? Are you from Spartan Robotics? Oh.
I just follow the thread.
Oh, you, okay. If you're a programmer, if you're an advanced programmer, he makes some really good points, and I am on board with it. I can expect a command-based template's probably going to change for the testable robot. It's a good set of videos if you want to learn some information. For right now, the command-based template it works very well for us, but it does teach us some of the industry improper ways of setting up some of our methods and subsystems and stuff. So, a place to put the project, select a new folder. We're in the Jumpstart demo, so we're good right there. Select folder. Create a new project. We'll just call this Create Jumpstart. And our team number, generate project. Yes. That one's a little bit quicker. And here again, what libraries are we going to do? Manage vendor libraries. Install. And we're off to the races and running. So hit the source, drop your source, SRC. In our Java tab, you can see that structure that we're all currently used to in Eclipse. So click on commands. Well, since we got a new thing, right click. Down there, create new command class. We're hard coding some things. We typically use a lot of Robotbuilder, so I'm not quite even on grip. Here's our command, different types of commands that we have. We can write a regular command, import that, give it a name.
So can you go back?
Oh,
sorry, I'm just.
Go back to that, hit escape.
So if you want to mess with some stuff and you found some code to test, you could use that run, or is it instant command? You could use that. Is that true?
What was the first
Like
one?
if, let's say you find some code that, hey, that looks interesting. I want to try this on my robot to see if it runs a motor a certain way, or you're experimenting with, say, you know what I'm asking?
Yeah, the instant command. We use that. The instant command doesn't have an is finished. It's set like a valve, and usually like a drivetrain. You're driving it. You're running that command forever,
Okay.
and then you'll have something will interrupt and shut it off.
Okay.
An instant command just toggles and done. It doesn't have an is finished. It's pretty much it initiates. I don't even think it has an X. You bring up the time command.
Okay.
I don't think it has an execute in it even. It just has an
command you want?
time command, second to the bottom.
Okay.
Call it time, or call it my time command, because you shouldn't name it as what it was called, because it'll cabbage it.
So it differentiates how you want the command applied to the robot, that function.
Yeah, and then oh, we want an instant command.
Yeah.
Yeah, sorry. Create an instant command. And so the instant command in the background has basically set the false immediately after. We initiate construct it and initialize. So whatever happens in initialize runs one time.
Okay.
And we could do that with a normal command just by setting the is finished to true.
Right.
So as soon as we fire it off, it will run the initialize. Oh, the true will be happening. So that just extracts all that out of there, and it's done in the background for us.
It's got templates it for you, so you don't got to do it all by hand.
Yeah.
That makes sense. All right.
So I got derailed.
Sorry.
No, that's a problem. Questions? I feel like I rifled this through it too quick. I expected a break in there, and it didn't break me. I talked about code snippets. We can look at that a little bit. I did link to our repository on there. If we go up to File, these are some of the things that I found really neat about this system here. Preferences, user snippets. Up here we're going to say what language are you in the Java. The easiest thing here to do is let's go into our example subsystem. And let's just create a dummy method down there. Underneath there, yeah, we'll go public void, do something.
So I say do something.
Yeah, do something. And then finish the method with the parentheses and squigglies. enter, and then just put a text, some text in there saying do something here. So //. Copy that.
All this?
Yeah, with the last bracket as well. You can go back to the user snippets, Java. You can kind of see up here, they kind of show us an example up here. So right after that green, the text, add a new line there, all the way down.
Right here.
And just up one right there, hit enter. First thing we're gonna do is we give it a name like our what we're gonna start typing. So we'll just put in there parentheses, do something. Yeah. So follow that template right there. Should I just do it? I know you haven't done it before yet.
What is the question?
Yes.
Is this package available for Linux or is it just Windows?
I believe it can be installed on the 3 primary platforms. I've been doing it on the Windows side, but I've seen on the betas that the Windows are the Mac and Linux.
They claim first won't support you if you run anything but Windows. Is what the claim is. That if you would send a request for first to help, they'll deny you.
So that's what our IntelliSense is going to pick up. And our prefix is, I'm just gonna, I can't talk and type at the same time. Maybe I'm spinning off in the wrong direction here. Comma. Body. Yeah. Save that. And now when I go to, if I start typing public, I see this. Oh, no, it was do something, wasn't it?
Yeah. There it is.
Do something. Oh, yeah, that's where, you're right.
Something. Do something. Type S.
Let's do this.
Do this. And there, all that code is just written out to us. I didn't want to go through the one-click installer because that takes it does take some time on different laptops. See if I missed anything in here. Any other questions up there? Yes.
Are you able to deploy to the robot from this?
Yes. Good question. Should we bring up our Robotbuilder?
Yeah.
Or bring up that other program that we had in there?
Oh, just the program we did last hour?
Yeah.
Where do we save it to? The desktop?
No, that was in that library.
Oh,
The FRC library projects. FRC projects, second one down. One more down. Jumpstart demo.
you ain't open. Should I just save the example subsystem or no?
No, delete that. Deploying, very good question. Bring up the driver station and so we know we're online with the. what's broken in the driving joystick.
We didn't finish this.
Yeah, delete those lines.
Delete this entirely?
Yeah, delete that line. The driver station up? So we're up. Okay, deploying code with from VS Code. Again, there's the quickest way. One of the ways is hit that 3-dot ellipse up at the top, and you'll have right in the menu deploy code. Shift F5, and it should pop up terminal. Yeah, it popped up their terminal, and it's right. It's doing the commands for us. And it worked the first time. That's kind of surprising. The other things we can do, like I said, Shift F5 is the quick key. The other thing, Control Shift P. Yeah, go ahead and hit Control Shift P. WPI lib. And somewhere in that list should be deploy code. Debug, deploy code is the second to the bottom.
Just do it again, or? No point.
You can right click on the menu also.
Pardon me?
You can right click on the menu too to deploy. Right on build.
Right on one of the icons in
Where
there.
it says build on the left side.
Right there.
Yeah, build that. Build that data. Yeah, at the bottom.
Alright, there.
Deploy
code.
Build
Thank you. As with Windows, everything, well, there's 3 ways of doing it. It doesn't matter which way you learn. Yes?
What does that debug robot code function do that I saw in the command palette?
I have not experienced. Anybody know what the debug does? I think you can set stop points. We had that over in Eclipse as well too. I haven't typically used it, but that's what that is, for setting the stop points.
Visual Studio?
Pardon me?
In Visual Studio?
There's a debug tool here too, debug code versus.
It's supposed to step by step run line through your code.
Yeah.
And it like one by one executes every line to make sure you don't run into problems.
Okay.
That's what it's supposed to do.
Can it do that when it's, connected to the robot and everything, or is that just?
I haven't used that tool, so I don't.
Okay. Yeah, I've never done anything with any debug.
I'm kind of along with you guys. If we're trying to debug, we'll write some prints out to the console.
You can just set breakpoints on the left and it'll stop where you want to stop it.
As you're connected to the robot.
Then you can hit like F6 or whatever, step over it, and then play with variable values.
I only one time quickly used it once. The big thing with this year is that one-click installer. It's smooth, it's quick. And right now, if you haven't already, you can go download the alpha version of this that's still on Street Step 5 and start getting familiar with this workspace. What that does is installs last year's WPI libraries. It's all bundled into one, so you don't have to manage the library. It's all they made in one package to bring it in there. You can import your code and start running it in Visual Code. The other thing with VS Code is you can change the color in the background. There's so many templates that you can change how it looks and feels. We can get to lunch early, it looks like today. It really is that simple. I went through it quick, but I've been really quite happy. Yes, question here? Terminal?
It also comes up automatically.
So, AJ, up there, X that out. Quick keys. X out the terminal at the bottom right-hand side there. Control that little tick mark. Control tick or tilde. We'll open up the terminal. The first time you install this the WPI libs, the first time you open it, you're going to be redirected to the Visual Studio Code website, and you'll have lots of reading to do to learn all the quick keys and how to make things coding quicker. There's also a thing, AJ, go select like the begin auto-generated. You can't see me point.
Yeah, I see it. Right up here?
Yeah. If you do a Control Shift L, I copy everything. See everything that says begin is highlighted right now. I do a Control Shift L. I have multi-cursor. And now I can change every line that has that same. So if you have you need to change, if you have that same variable somewhere in that code, you can change a whole ton of them. The other thing you can do is multi-cursor, escape out of there, Control Shift arrow. We'll start, no. I forgot that quickie. In that link to my snippets, I have other things I've been trying to make notes of. There's also you can do columns of selections too. Every match. Questions otherwise? Once you get it installed, the environment's the same. You're going to program your robots the same. There's nothing that's changed that drastically. They haven't changed anything. Other than, I don't think I covered that. This year, I say, yeah, the crossroad electronics, you do have to, I'm mixing the two classes together. That's the one thing that you will have to install, even if you're not using Talon, is that crossroad electronics diagnostics tool to look at your CAN bus. Right now, there's no way to set the IP address, the static in the roll rail. There's a few people chattering like, well, we want static, but it shows you the IP, but it does not allow you to set static IPs. I'm not sure if that's going to change. It's installed. Yep, that's the WPI tool, Robotbuilder installed. AJ, open up Robotbuilder. Now, show how to do it. Sure. Hit the three dots over there. Start tool. And there's your tool. Those are tools. Otherwise, Austin, browse to that. I'll do it here. All your tools are going to be installed in that folder that they created. Again, it was C, users, public, FRC tools. There's this folder called tools. Here are all those tools that are on that list as well. Again, remember, we're normally used to clicking the jar. We're not going to click the jar. We're going to click the VBS because this is actually going to launch the program with the correct version of what? Outline viewer. Yeah, this is outline viewer, but it's going to launch the application with the correct version of Java. Thank you. And there's our. So they haven't really changed anything with the tools other than this year's big change is the change from Eclipse to Visual Code. Visual Code is not an IDE. It's more like a really enhanced Notepad++. With you can write custom or custom extensions. Yes.
Why is Robot Map not used this year?
Robot Map?
Yeah.
I don't know. Have the theories on behind that. What I understand is they want the objects to live in the subsystem or be. I can't think of the term right offhand. Maybe you're following that thread. What did he call it? What did he say that? Or he didn't really cover Robot Map, did he? Oh, I can't. The term is that they want better encapsulation. That's what they're saying. So they encapsulate the objects in the subsystems versus outside the subsystem. It was a decision that they did on the WPI lib side that developed in the library. You can still create it. You can go create that folder. Look at last year's code. How do you just create an instance of Robot Map, and then still in your subsystems make a copy or alias that. So still, that's on you now though. That thread that we've been talking about before, what he is saying is don't put any objects in your classes or in your subsystems. You want to inject everything through your constructing method. So if you need a talon, send a talon in. If you need an input, send an input in. Nothing should be actually in that class or that subsystem that actually gets instantiated inside there. It should be all done almost in robot map and then injected in. And the reason they're doing that is, and he has a really good point, it's called testing. You can mock up inputs that have no robot at all and mock it up. So yeah, you can do testing. You can mock up an instance of Talon SRX or an input, send it into the subsystem. You can instantiate that subsystem, and it won't break because it's not actually depending on any other external dependencies. So, yeah, if people want to head out and stay and talk, we can do that right here on the one-on-ones. We look closer at here, and we can you want to click around into the VS Code. Otherwise, I encourage you to go at least download the alpha. Preview that for the next 4 weeks a little bit, get a feeling of some of those snippets. Those are really high speed, really quick tools, especially if you have multiple programmers. If you want the same basic structure and format on your code, everybody will have the same library of snippets. So thank you, and thanks for the questions, and I'll be available. Also, we're going to be doing this after lunch. We're going to be back in this room, and we're just going to have an open discussion on that hour. Primary focus on Robotbuilder. We didn't get to finish, so if you're in that class, we can finish the Robotbuilder and spin off on VS Code. So thank you.
Thank you.